Okay, share the screen. Okay. All right. So everyone should be here, right? That means that you loaded the 3 images into the tensors. We're working with images a lot, okay? Because in machine learning, AI, images are a big thing. So a lot of examples will be images. So definitely important that you understand this. This is actually pretty solid and something that you will be using. Things like permuting the image, going from tensors to NumPy, reading in images, and creating batches of them. All right, so that actually we're almost done. We're gonna do 2 more things to this batch. One thing is, whenever you're dealing with data and machine learning, you want to do something called normalization. This is very important, okay? And pretty much every time that you do machine learning, you need to normalize your data. And what you're going to encounter is that the results improve. So machine learning likes numbers to be in scales from 0 to 1, or scales where they're centered at 0 and then go from -1 to +1 or something like that, versus these values. So in this case, this is nice because the values here look like this, and now we're going to convert them into something else. Okay, guys? So that's the objective. So we're going to change them. We're going to do some fancy tensor operations, and hopefully you can, let me know if it's confusing or if there's something that you don't understand. All right, so we're going to call this normalize the batch. Okay? So this operation can be done very efficiently on tensors. So I'm just going to do that. And so what I want to do is I want to take all the values and apply a formula to them, okay? The formula should be, so I'm going to actually write it here. Formula should be X, let's do this, X norm, which should be X okay, let me just try that. Yeah, so that. So we are going to take X minus mean, and we're going to divide it by standard deviation. Okay, so that should be the equation that we're going to implement in all our samples. Okay, so what we're going to do is, we have 3 images, so we're going to take the mean of the 3 images, right? And we have, of the 3 images, we're also going to take the standard deviation, and then we're going to take the original image and we're going to subtract the mean and divide it by the standard deviation. This is going to be done on a pixel basis, okay? So it's on a pixel basis. So that seems like a lot of operations, right? But that can be easily done with tensors, actually, in just a few lines of code. So that's the beauty of it, okay? Everyone understand the basic idea of what we're doing? So we're just taking, for every pixel, we're grabbing pixel 3 by 5, and for the 3 images, we look for 3 by 5, add them, divide by 3, that's the mean. And then we do the same for the standard deviation. Okay, and then we apply this formula on a pixel basis. So the other problem that we have is that we don't have black and white images, right? We don't just have one grid. We have RGB. So there's actually 3 grids, right? Of 256 by 256. So there's the R, the G, and the B. So we have to do it for the 3 channels. So like we want to average out the reds, the greens, and the blues. Do you guys see that? And again, that's even more complex, right? And we can do this in 5 lines of code with a tensor. All right. Now, this is hard. Okay. I don't want you to think that you can just like in 10 seconds think of this. This would take you a while to like work out. But this is just take it as another example of how things can be done with tensors. All right. So let's go ahead and get started. So there's a couple of ways that we could do this. We're going to do this approach, okay, which is to iterate. We're going to do a for loop, and the for loop is going to go over all the channels. So that way we're going to do channel R, then G, then B, 3 iterations. So we need to know the number of channels. So that's n channels equal. We can get the number of channels from batch, right? So batch dot shape. So since you guys are indexing experts now of tensors, what's the index value there? But you need one specific I if we were iterating, but we need it. We need that value. Is it 0? I want the channels. Not 3. Not 2. It's the second one, right? So remember, it's the batch. So whenever you get confused, just look at the shape. So batch of 3 samples, 3 channels, 256 by 256. Do you see what I'm saying? This is what I wanted, the channels. Got it? All right. So then that would be 1. Yes. All right. So now I've got that value of 3. Okay. All right. Now we're going to iterate through this. I'm going to say for C in range. And here I'm just going to use n channels to know that this helps a lot because it tells you what you're doing. N channels. So you're iterating and you're going to calculate the mean for all the reds and not mix them. You don't want to mix them because red means different than blue than green. It's the whole point of RGB. So now we know that the equation should be something like batch, the contents of batch minus mean divided by standard deviation, right? We know that. So standard deviation. And then this is equal to also batch something. Why? Because we're grabbing from the batch, that cell, right? We're subtracting the mean dividing by standard deviation, and that new value still gets assigned to the same cell position, the same pixel. It's like I grab pixel 3 by 3, and I want to normalize it and add it back to its slot. Okay, guys? That's what we're doing. So I like this example because, it's like everything that you did with tensors, but, it's got a purpose, right? Which is the channels. So we got to think about this one. There are, here we're going to do, let's see. We need to calculate the mean and the standard deviation before. And also the standard deviation. Now I'm trying to think, it's probably easier actually. And should be the same result. To just take the mean of everything in the of the grid of 256 by 256, I think we can just average the whole thing. So it'll be a little bit easier. So let's try that first. That should work. So let's do torch. We'll need to print this out to see if it's working. So torch mean, right? That's what we're going to use to mean. So So now we're going to say we want all three images. We know that much, right? So what is all three images? It's 0, 1, and 2. So we can probably use colon. Colon would usually say all three images, right? If we wanted just the first image, right? If we wanted just the first image, we could say that. If we wanted the second image, the first two images, something like that, right? But if we want all three, we know we can just do that. Yes? The thing we need to separate by is what? The channel. We don't want to grab all the channels, right? We know that the channels are in that second dimension, right? So we can plug in C there because there's only three channels, right? So first iteration, it'll grab channel 0, right? Second iteration, it'll grab channel 1. And third iteration, it'll grab channel 2. Do you guys see that? So it's going to grab all the R, all the G, and all the B. So at least we're separating those out. Okay? Now here, what do we do for this part? Well, we can probably just grab all the on one axis and all on the other axis. Do you see that? And just average those out. Does this make sense? So we're grabbing all, but here we're definitely we're not including, like if in the first iteration, this is 0, so it's not including 1 and 2. So it's not including the G and the B. Do you see that? And then we grab everything else and mean that. Okay? All right, so just take the mean of that. And then we're going to try the standard deviation. So that's going to be torch. Okay, standard deviation, parentheses. Again, this should be the same idea. All images, comma, specific. Oh, let's make it consistent. Specific channel C, and then all other values. Okay, and we just take the mean and the standard deviation of all. That should be a little bit easier than on a pixel basis, which is what I wanted to do initially. I don't think we need to do that other one. Although that one can be done also, but we would need to do what is called element-wise operations. So let's try this. Okay, this should give us means. Let's print them out. I actually want to see what these are. So I'm going to do print mean. It should be a value, I think, not a grid. And print standard deviation. Okay, I'm going to comment this out because otherwise it'll error out. There's only 3 channels, so let's try this. Invalid syntax. Oh, I didn't give it, right? Yes. Good catch. Good catch. Good catch. All right. So I did this without actually invoking the tensor itself. What's the tensor? It's actually batch, right? Sorry about that. Yeah. So batch is the tensor that we are indexing and slicing. And out of that, we take the mean and the standard deviation. Good catch. And I'll do the same here. Out of batch, at the square bracket here, and square bracket there. There you go. Exactly. Very good. All right. So now let's try it again. Okay. Oh, this error, yeah, it's because they're integer and I want to do a mean operation. So this, to solve it, just do batch equal batch dot float. These little errors, I mean, you gotta watch out for. But notice the description. It says the function mean of torch could not infer out data type. Input data type must be either a floating point or a complex data type. So basically it's telling you do a floating point, and it's saying it got a byte because this is how it stores things at the lower level. So just change it to float. Okay, so that's what I'm doing here. I changed batch to float type, and then hopefully the mean operation will work. Got it? All right, so let's go ahead and try this one out. Okay, so yeah, so it took the mean and the standard deviation of R, that's it. The mean and the standard deviation of G, that's it. And the mean and the standard deviation of B. Do you see why we want to separate out the channels? Because they're not exactly the same, right? So it seems to be what? Lower on the B, on the blue, and higher on the reds, right? That seems to be what it's telling us. Does that make sense, guys? So we separated this out, and now we calculated mean and standard deviation. So now we're just going to apply it to the actual batch. So that's the last part. We can comment out these print statements. So comment out these.
I think you want something I don't have in my batch statement has no attribute shape.
Are you behind? Are you like up here somewhere?
No, I'm down with you guys down in the batch float.
Because we did batch shape here.
Right.
Did this work for you?
That's it.
Okay, so where's your error? I'm sorry.
Well, that's one we just read.
Okay, so down here, yeah.
In the in channel, like there, the channel equals batch.shape 1, stating that the built-in functional method object has no attribute shape.
Oh, okay. So this one here, you mean?
Yes.
Yeah, yeah. Did you write it exactly like this? Because we named the variable batch. When you ran batch, this one here, do you get these values?
Yes, it is.
Okay. And then this doesn't work?
No.
That should work.
Oh, that's right. Never mind.
Figure it out?
I ran the function before that.
Okay.
I think.
So you got it?
Nope. Now the I think. Somewhere in here I have forgotten. That's what I had the problem before.
Works. All right, so let's keep going, guys. Well, this part you can do, right? So this is a nice, this part, the first part was a little bit harder, but this last part, maybe you can figure it out, right? It could be like an exam type question that involves slicing and indexing. What do we need to do? We want to grab the values in batch that look like these, right? And normalize. Do you see what I'm saying? And now you have the mean and the standard deviation. And you need to do it in one line of code. So how do you do it? You see what I'm saying? So you've got the mean here. We got the standard deviation here. We printed it. So then we just need to change the values from the original here batch to the new normalized versions. So I'll take ideas, right? So obviously square brackets, right? So how do you write these index and slice values? we've got one mean value and one standard deviation value for each channel, correct? Do you guys see that? And so we want to change all the values here, 195, 126, 137. So we want to do 195 minus mean divided by standard deviation. We want to do 137 minus mean divided by standard deviation. We want to do 77 minus mean divided by standard deviation. Do you guys see that? That's what we want to do. Okay? For all images too, right? So that means, so let's think of the indices. The first one would be what? If we want all images, colon, right? Yeah? Okay, what about the second dimension? What is the second dimension? The channel, it's C, right? Very good. Why C? Because for the reds, we apply the mean for reds. For the greens, we apply the mean for greens and so on. So this one we need to index with the letter. And this should be the exact same, right? Right? And then we would just do either this, or remember that when it's that, we can just leave it like that. And it just infers that by default. Got it? Guys? That should be it, right? So now that's it. So now we normalized it. So hit run. How do we, what do we need to do? Now we need to run batch again and see what it looks like, right? It should be look normal, like normalized values. So batch, hit run. What do you think? Do you think it worked? That's your normalized data. Now, do you always have to do it like this? No, I mean, there's built-in functions in PyTorch that we can use that will make our life a lot easier. Okay, but you know, my goal with this one is just to do even more tensor operation examples. All right, so let's do one last thing, and then we'll conclude this part of processing an image, right? So what about, do you guys remember adding dimensions to a tensor? We did that, right? And we talked about something called squeeze and unsqueeze. Do you remember what that was? It's like taking a Rubik's Cube and making it into a flat page, right? So if I have a Rubik's Cube, it's three-dimensional, and then I do this, I squeeze it, so then it's flat. You see what I'm saying? And then unsqueeze would be the opposite of that, like adding a thing. So if I have two-dimensional and I unsqueeze it, what do I have now? A Rubik's Cube. Got it? So we're gonna do that and play with it, right? So let's do down here with batch, actually. Now let's remind ourselves what batch looks like. So batch, we're gonna print. I want the shapes of batch, right? Everyone with me, guys? So I want batch size, shape, sorry. Shape. Okay, so it is 3 by 3 by 256 by 256. It hasn't changed. But let's say that I want to add yet another dimension, right? Even more dimensions. Say I want to add one dimension in the front, so I can do what is called unsqueeze in Torch. So let's say batch, oops, no. Let's do it here. I'm going to do batch underscore new, and I'm going to invoke torch dot unsqueeze. Unsqueeze. And it takes batch again. But now I can specify where I want to add this new dimension. I can add it wherever I want, at the beginning, at the end, in the middle. This is really advanced stuff. But sometimes doing an unsqueeze or a squeeze and then an operation can really be very effective, right? And save you a lot of time. So I do 0 here. And then I'm going to print the shape again. And you will see that it didn't work. Oh, yeah, because I need to print batch new, sorry. So batch underscore new, like that, okay? So now I'm going to hit run, and you can see I've added a new dimension. what is the dimension? What are the dimensions of this tensor now? 1 by 3 by 3 by 256 by 256. So you can do whatever you want with this. This is a hypercube at this point, right? 5 dimensions. We can also do it somewhere in the middle. Like that. Let's do 2. Do you see that? And I can conveniently add a dimension as I need it. Make sense? Okay, so yeah, that's kind of where we are. So I made, you know, I added something. All right, that concludes this part, just playing with images. So I'm gonna go ahead. I'm gonna stop this video.